So today we're going to review some notes on how to create data tables, which is the next step of the inquiry process. So if you look at your INB, you can find these notes about data tables on slide number 21, the left-hand side, and you can use those notes for future reference. Okay, everything that's in this video is also in your notes on slide number 21 in your INB. Okay, what is the essential question for this set of notes? The essential question is, how do scientists set up tables for data collection? So by the end of this set of notes, I would like you to start to have an understanding of how to set up your own data table. And you're going to end this video with actually setting up a data table for the bread mold lab. Okay, so hopefully what you learn in this video will help you set up the data table for the lab that you are doing at home. Okay, so what is a data table? A data table is something that is used during an experiment to collect and organize data. So a lot of times people will get data tables confused with graphs. A data table is not a graph. Okay, a graph is something that you make after the experiment is over, and it kind of is it's a visual that represents your data. We're going to talk about graphs later. A data table is something that you set up before you're actually ready to collect your data. Okay, you have to set it up ahead of time. So I'm going to write that in here, that a data table is something, and if you want to add this to your notes on slide number 21, you can. Something you set up before, okay, a data table is something that you set up before you actually collect your data. Okay? A data table is something that you set up before you're ready to actually collect your data. And I will let you decide if you want to add that to your notes, you can, but you don't have to. Okay, so down here, this would be an example of a data table. And as you can see, right, there's a bunch of data filled in down here. So this data table right here was set up before the experiment was over. Okay, it was set up before it was actually time to collect data. And then whoever the scientist was, right, they used this data table to record their measurements at the end of their experiment. Okay? Okay, data tables have both columns. Okay, columns are the ones that go up and down, and rows. Rows are the ones that go left to right. Okay, so let's look at this data table down here again, right? All of these, okay, this one, this one, this one, and this one, those are all rows, okay? And the columns are these ones, the ones that go up and down. These are our columns, okay? These are our columns, and these are our rows, okay? Let's go ahead and go to the next slide. A data table should include a title, okay? So every data table should include a title, and the title of the data table needs to include both the independent and the dependent variable. Both variables, the IV and the DV, should show up in the title. Okay, so let's take a look at this data table right here to see if that's true. So you can see that we have a title right here at the top, amount of liquid absorbed by paper towels. So in this case, the independent variable, the thing that we're changing on purpose, is the type of paper towel. And the thing that we're measuring to see if the type of paper towel makes a difference is the amount of liquid that was absorbed. Amount of liquid is the DV, okay? So we've got amount of liquid and the type of paper towel. Both the IV and the DV are included in the title, okay? So this is a good, solid title for this data table. Amount of liquid absorbed by paper towels. You don't want to just call it paper towel table or liquid table. You want to make sure it's a really detailed title so that when someone reads your data table and they read the title, they know exactly what your experiment was about, okay? The next thing that's really important to mention is that you want to put the independent variable in column 1. So I want to underline that. The independent variable in column 1. and you want to put the dependent variable or your trials in row 1. So let's look at what that means. So in this case, our independent variable is the type of paper towel. That's the thing that we're purposely changing. So in column 1, right, columns go up and down. This is column 1 right here. So in column 1, we are going to put the independent variable, which in this case is towel type. So you can see it says towel type right here. And we could have named the towel types. I forget the towel, paper towels, brawny, I think, and some other ones, right? But we just called them towel type A, B, and C, 3 different towel types, okay? So you can see that we put the independent variable in this first column, okay? Now, what are we measuring about each towel type? Well, our dependent variable is the amount of liquid that each towel absorbs, right? And it looks like we're measuring that in centimeters squared, okay? And you can see that right here. So in the first row, okay, this right here is the first row. Remember, rows go from left to right. In the first row, that's where we're going to put the amount of liquid that was absorbed. Now, why don't we just have one column here for amount of liquid? Well, because we have to do multiple trials, right? You never just want to do one trial, because if something goes wrong with that one trial, then you don't have any other data to back it up. Also, sometimes things just happen by chance, right? And there's going to be some natural variation in your measurements. And so it's really important to do multiple trials so that you can get an average, and your data is more reliable that way, okay? So you can see that we've done trial 1, trial 2, trial 3, trial 4, 4 trials, okay? And then we're gonna end with an average. Now it's really important, and I can't see this very well, so I'm just gonna erase this. It's really important to put your units in parentheses here, okay? So you can see, we said trial 1, centimeters squared, in parentheses. Trial 2, centimeters squared. Trial 3, centimeters squared. Trial 4, centimeters squared, and average centimeters squared. Those units are really important because there are a lot of different ways to measure liquid, right? We could measure ounces of liquid. We could measure pounds of liquid. There are a lot of different things. There are a lot of different ways we could measure the amount of liquid. And in this case, we are measuring the amount of liquid in centimeters squared, okay? So these right here are called your units, and it's really important to include units in your data table. And if you want, I will leave it up to you, but you can add this to your notes on slide 21 on the left-hand side if you want. But you need to include your units, which in this case is centimeters squared, so we know how we are measuring the dependent variable, what our units of measurement are, okay? So then you can see that this data table has been filled in, right? So here's how you read this. I'm going to use a different color here. So for towel type A, trial 1, okay, I'm going to go over and I'm going to go down, and you can see that towel type A absorbed 25 centimeters squared of liquid for trial 1, okay? What about towel type A, trial 2? Okay, well, trial 2, and then towel type A all the way across, 28 centimeters squared, okay? Towel type A, trial 3, 24 centimeters squared. Trial 4 for towel type A was 31. And then we got an average, okay? So right here, this is the average 27 centimeters squared is the average amount of liquid absorbed by towel type A, okay? It's all 4 of these trials averaged together. And we will talk in the future about how to calculate an average. You will need to understand how to calculate an average. Right now, that's not hugely important, but you will need to learn that here soon. So we'll cover that in the next couple weeks. Okay, and then, again, down here, towel type B, trial 1, 26 centimeters squared. How much liquid did towel type B absorb during trial 4? 22 centimeters squared, right? If you average all of these up, on average, towel type B absorbed 24.5 centimeters squared. And then all of the data for towel type C is in this last row right here. So on average, towel type C absorbed 20.5 centimeters squared of liquid. Okay, so hopefully this gives you an idea of how to read and fill in a data table like this. Okay, so for your processing activity today, what I would like you to do is I would like you to go to the bread mold lab write-up in your INB. It's the second page of the bread mold lab write-up, so that it is on slide number 35 for you, okay? So on slide 35, the second page of the bread mold lab write-up, you're going to see that there is a space for you to make a data table for the bread mold lab. And what I would like you to do is I would like you to try to make a data table for the bread mold lab based on what you just learned. So take what you learned about data tables today and see if you can make your own bread mold lab data table. You are not actually collecting data today. You will use this table to collect your data and record the results of your experiment when it's time to collect data. But we need to let our bread sit for a little bit longer first. Okay, so you are just setting up a data table so that you have a place to record your data when it's time for us to check our bread. Okay, and then there is a stop sign here. So again, that means pause the video, stop the video, do this activity, okay? And then I want you to come back to this video because there is 1 more minute of video that you need to watch. So pause the video, go try to do this activity, and then you're going to come back to this video. If you don't know how to build a data table in Google Slides, I included, in question number 1, I included a link to some video directions about how to build a data table in Google Slides, okay? So pause the video, come back in just a minute once you've tried to build your data table. Okay, this is what your data table should have looked like. So go back to slide 35 in your INB and check to see if you made your data table correctly. And if not, then you need to adjust it, okay, so that it looks like this. So you may not have had exactly this title for your data table, but you should have a title that includes both hand washing and mold growth, right? Because the independent variable in our experiment is the whether or not you washed your hands or how you washed your hands. That's the IV. And the DV is the bread mold growth, how much mold grew on your piece of bread. Okay, so your title should say something like effect of hand washing on bread mold growth, or something like that, that includes both the IV and the DV, okay? The independent variable in your experiment is hand treatment, right? So we talked about that. We said the thing that we're purposely changing is what you did with your hands before touching the bread. So in this first column, right, this is column number 1, columns go up and down, you should have labeled this column hand treatment, and then underneath it there are 4 types of treatment. Untouched, that's bag number 1. Unwashed hands, that's bag number 2. Hand sanitizer, that's bag number 3. And then the soap and water one, and that's bag number 4. Okay, now for each one of these hand treatments, right, for each one of these tests, you set up 3 trials. So across the top, right, you should have had trial 1, trial 2, trial 3, and then at the end, once we've done 3 trials for each one of these, we're going to get an average. So you should end with your average. Okay, now remember, your trials go across the first row, right? And you want to put your units here. So in this case, what we're measuring is the amount of mold. So I went ahead and said trial 1, amount of mold. Trial 2, amount of mold. Trial 3, amount of mold. Average amount of mold. So that we know what it is we're measuring each trial. Okay, we are going to be measuring the amount of mold. We don't really have the equipment to measure the amount of mold in grams. So we're going to have to use kind of like a 1 through 5 scale to measure our mold, and we'll talk about that as we get closer to the end of our experiment. Okay, so you'll notice that my units don't say grams or centimeters, right? My units is just amount of mold, and that's because we're going to be using a scale to rate the mold on our bread. Okay? All right, so go back to slide 35 in your IMB. Make sure that your data table looks like this, so you have a place to collect your data when it is time to do so at the end of the bread mold lab. All right, thank you, everybody. Bye.